Order in the court. Order in the court. Mr. Duracell, you have been charged with the crime of battery. How do you plead?
Guilty. I am indeed a battery.
Bill Nye the Science Guy. Science Guy.
Batteries. They charge a lot of our everyday items. Everything from your car to, your cell phone is all charged with batteries. But how do they work? Well, a battery is made up of 3 parts. The cathode, or the positive end, the anode, or the negative end, and an electrolyte, which is a liquid that has charged ions floating all through it that let the electricity pass. Now, when those electrons are able to flow in a circle, or a circuit, that's what gives us electricity, which lights up our whole world. But why do batteries work? Well, let's head over to the Board of Science.
The Board of Science.
For a little explanation. So, different metals are better or worse at gaining or losing electrons. That's why some batteries are better or worse than others. So some batteries can produce a lot of energy. Whoa, too bright. And some can only produce a little. Hello? Oh, thanks. You see, some metals are really good at giving or receiving electrons. Think of it like football. If you have a good quarterback who can throw that ball really far and really fast, and a receiver who can catch that ball well and run with it fast, then, well, your team's going to score a lot of points. So, if you have a metal that's really good at throwing those electrons, and a metal that's really good at catching those electrons, well, then you're going to get a pretty good battery. Now, all of this happens in a circuit. Now, here's our battery. The electrons leave the battery from the positive terminal and start traveling around the circuit until they reach an LED. Now, at this LED, the electrons are going to pass through, creating the light that you see in a light bulb. And after that, they go all the way back around to the negative terminal of the battery, ready to start their journey all over again. So first, we're going to need to make a diagram of what our battery looks like. We're going to use some aluminum as our base. Then, on top of that, we put a zinc washer. On top of that, we're going to put a piece of cardboard soaked in vinegar. And on top of that, a piece of copper. Now, I use some hammered pieces of copper pipe, but you can get the same effect by using a penny. Now, that's one cell. And one cell could power something very tiny. But you can keep stacking cells to make it have more and more power. Zinc, cardboard, copper, zinc, cardboard, copper,
zinc, cardboard, copper, zinc, cardboard, copper, zinc, cardboard, copper, zinc, cardboard, copper, zinc, cardboard, copper.
And you could hypothetically stack it all the way to the sky. But we're just going to use 7 cells in our battery. Just remember, the more cells, the more power. Alright, so let's just fold this up. And we'll send it off to see how many volts we should get. Hey, that was pretty fast.
Now, it says here that we should produce a theoretical voltage of 1.10 volts for one cell, and because we have a total of 7 cells, we have a theoretical output of 7.7 volts.
Well, let's go to the lab and see how our battery does. Come on!
I'll do this.
That was a lot of fun. Our battery was able to produce 6.804 volts of power.
Wow.
Now, let's see. If our battery produced 6.804 volts, and it was supposed to produce 7.70 volts, then that means, one second, let me run some quick calculations. Our battery was 88.4% efficient. Quite shocking, isn't it? Now, you tell us at home how much power your battery created.
It's really amazing how batteries help us in our everyday lives. Now, if you don't mind, I'm a little tangled up and I think the camera battery's about to die.